we're back. And now we're going to talk about the last component, right? We've talked about independent variables. We've talked about how to randomly assign to those independent variables. Now we're left with the dependent variables, the DVs. These are named because theoretically your score on this type of variable should depend on which level of the independent variable you experienced, right? So things that we can use as dependent variables, this is not a comprehensive list, would be outputs. Anything that the participant is outputting. So like how productive the participant was after the treatment, any errors that they produced, any changes in attitude that they display, or opinions, how well they're performing, any feelings that they're expressing. Like these are all just the sorts of kinds of things that the participant can emit and we can measure. So a good way to think of dependent variables are any kind of response or behavior that is measured in some way. The participant might be writing things down. The participant might be saying things. The participant might be acting in a certain way, and the researcher's writing things down, right? Like there's different ways that the dependent variables can be defined and measured. Here's a little cartoon I found where the independent variable says, nothing you do affects me. I am independent. And then the dependent variable says, well, some things you do affect me. So independent variable, the groups are independent of each other, and the independent variable does not get in any way, shape, or form changed or impacted by the dependent variable. But the dependent variable, we're hoping in our design that the experimental condition will score differently from the control condition on that dependent variable. We're hoping that what the independent variable is will determine the dependent variable score. So that's what we're trying to do. We're testing the hypothesis that the independent variable is the reason for the dependent variable score. All right, so ways to record or measure the dependent variable. Okay, so we see this person's wearing an EEG cap, and we can see the results of it up here on the screen. Those are actually just both visual displays of it. What's really happening is there's a computer that's storing all this, right? Like that's recording the dependent variable. How do we measure that? I mean, you would need to measure the amplitude above baseline or below baseline and things like that. Like the actual measuring is separate from the recording. So different things that we can record or measure would be things like correctness. Another word for that might be accuracy, right? So maybe on a memory test or on a knowledge test, we would have that. Rate, the number of behaviors during some specific time frame, like how many times did they tap their finger during that time? How many words did they generate? How quickly were they generating these words, right? These would all be examples of rate. Frequency is tied to rate. I mean, you're going to have a higher rate if your frequency is larger. Like how quickly are you generating words? How often are you would be another way of saying frequency. Degree, like how are you doing it a lot? Are you doing it hard? An example of a degree measure would be one stand-in for aggression in research on aggression is to have people turn the knob on what they believe to be the volume on their neighbor's headphones, and they think that they are determining the volume of the white noise that's going to blast their neighbor in their headphones. The truth is there's no neighbor over there, so don't worry, nobody gets hurt. But that intensity, the degree to which they're turning that knob is what was being measured. Like after you've been frustrated, do you turn that knob higher than when you're not frustrated? That kind of thing. Amount would be like the total number of responses, the total number of words that you generated, something like that. Latency, how long did it take between when you were given the cue and when you started doing the behavior? So like in sleep research, they oftentimes measure the latency for sleep onset. So how long between, okay, good night, and actual falling asleep did that take? Duration, how long did you do it? Again, with sleep, we might measure how long you were sleeping. Duration might be, how long did it take you to generate your list of words? Stuff like that. So these are all examples. There's probably more that I didn't think of, that different categories maybe that I couldn't think of, but these are the ones that came to mind for me that are different ways that we can measure dependent variables. Here's an interesting question. Should you measure more than one dependent variable in a single study? There's nothing to prohibit you from doing it, that's for sure. You're allowed to do as many dependent variables as you want. You can do whatever you want in your study, right? But I would go back to the KISS principle. Only do it if you need it. Like, is it going to add understanding? Is it going to be interpretable? Is it going to help? Like, don't do it just because you can and you might think of an idea for what to do with it later. Don't do it for that reason. Think about it like you're the participant in the study. Do you want to find out that you gave a bunch of answers and spent your time and the researcher didn't really know what they were going to do with that information? Probably not. You probably would like to think everything I'm doing is going to be included in this study. Everything I'm doing is worthwhile. And so I always like to say, if you don't have a plan for it, don't include it. And we can always call this first study. Maybe we've got 10 participants under our belt and we say, you know what, this is going to be study 1, or this is pilot data, or this was us learning what needed to be done. Add it in if it makes sense, but don't just stick it in there because it might make sense. Get all the information you can. We'll think of a use for it later. That is not a good policy when doing research. You want to always have a goal. So, some characteristics of a good dependent variable. First, it's valid. It's measuring what it's claiming to measure. You don't want to use a tool that measures something, but not what you're actually trying to measure, right? So if you're really interested in, let's say, analytic thinking, you probably don't want to administer a bunch of multiplication problems and say that's analytical thinking, because there's more to analytical thinking than being able to solve math problems, right? But it's easy to make a math problem test, isn't it? So I'll just make math problems. Why bother with something else? It's probably not a good policy to just get it because it's easy. You probably want to use something that's as close to what you're trying to measure as possible. So maybe I'll get my hands on an actual intelligence test. It's directly related to the independent variable. There's no way for the independent variable to influence the dependent variable if the independent variable has nothing to do with the dependent variable. I've been involved in research where we had an independent variable, we manipulated something, and then we had a dependent variable that it turned out that manipulation was not actually impacting that dependent variable, that it didn't really matter which level you were in, you scored the same way either way. So it's pretty clear it was not related. It's frustrating when you discover it because sometimes mentally you think it's going to go. I was involved in a study where we were using a particular measure of cognition that isn't very hard. Let's just put it that way. It's not very hard. And so everybody was performing exactly the same way, regardless of their condition, I think because it was just too easy. And so everybody was able to do it really well. And so I couldn't distinguish between people who might have been distracted and should have done less well. So now I'm left trying to figure out, were they not distracted? And that's why everybody performed the same way. Or was this not a hard enough cognitive task to reveal the effects of distraction? Right? You don't want to be in that situation. So you have to find a good independent variable that is clearly related to the dependent variable. And that way you know that you're having the effect that you're claiming to have. We need a dependent variable that measures the effects of whatever manipulation that's occurring. So we need the dependent variable to be the result of the independent variable. We need to be reliable. You'll notice that's bottom of the list. Remember, reliability means that that measure produces consistent results across different administrations. In psychology, we have a lot of characteristics, a lot of dependent variables that you might perform better on one day than another day. And to a certain extent, we want a dependent variable that's not super reliable within the person because we want it to be malleable by the independent variable, right? So let's think of the Beck Depression Inventory, right? We're going to assess whether our treatment for depression worked by comparing their pre-test Beck Depression Inventory to their post-test Beck Depression Inventory. We don't want the Beck Depression Inventory to be so reliable that no matter what intervention happened in the in-between, you still get the exact same score the second time. Like, that would be a highly reliable test, but it's immune to the effects of maybe any improvements that you might have made as a result of the treatment that was provided if you were in the experimental condition. So we need it to be reliable enough, but not so reliable that you'll still get the same score even if your depression has actually improved, right? Like, that wouldn't be good. So I put reliable farther down on the list because we want it to be sensitive to improvements or changes, right? So I put it farther down. So I put a list here where we've got an independent variable on the left and then a dependent variable that would probably be a good example of something that would go with that, right? So if I'm trying to test out whether people perform differently, whether instructions to learn impact people's ability to remember things, a memory test makes a lot of sense, right? If I want to test out the effects of having music present while studying, a test score makes a lot of sense. Whatever you were studying during that music or not music, give a test on that subject, right? If I want to see whether people learn better with handwritten notes versus typewritten notes, maybe I give a test to make sure that they're even able to recognize what the words are, right? Maybe the handwriting is obscuring what the words are. So we can have different kinds of dependent variables that are very nicely tied to different kinds of independent variables. You just have to think outside the box to figure it out. All right, let's stop here and come back and talk about confounded experiments.